Hello everyone. In this chapter, I'd like to explain the direct current circuit. First topic is the electromotive force. Second topic is the Kirchhoff's rules. Third topic is the RC circuit. Fourth topic is the RL circuit. Fifth topic is the LC circuit. Last topic is the LRC circuit. First topic is the electromotive force. This figure shows a very simple circuit. Increase in the potential energy is due to the batteries. A battery is a source of the electric potential. This potential is used in the resistors and returned to the terminal at lower potential. The influence that makes current flow from lower to higher potential is called electromotive force, EMF. The unit of EMF is a volt, or joule per coulomb. For example, a flashlight battery is a 1.5 volt. Source of EMF. So we need to apply some force to transfer the charges from the lower potential to the higher potential. We apply the non-electric force because the electric force is acting to the downward directions. So we apply the different force than the electric force. For example, mechanical force or chemical force to transfer the positive charge from the lower potential to the higher potential. So non-electric force is acting on charges to move from a lower potential terminal to a higher potential terminal. Sometimes internal resistance we need to consider. Charges in the source of EMF encounter the resistance. So internal resistance we consider as R. Then drop of potential across the internal resistance is expressed I is the current times R. So net potential is a little smaller than the generated potential of epsilon. Net potential of V is equal to the epsilon minus IR due to the internal resistance. Okay, then next topic is Kirchhoff's rules. So Kirchhoff's rules has two rules. First one is Kirchhoff's junction rules. This is the algebraic sum of the current into any junction should be zero. So sum of the I have to be zero. So in this case, the two current is flowing into the disjunctions I sub 1 and I sub 2. And the same amount of the current is flowing out from the disjunctions. So flowing current is calculated as sum of the I sub 1 and I sub 2. So no production or disappearance of charges. So this is a Kirchhoff's junction rule. And the second rule is a Kirchhoff's loop rule. The algebraic sum of the potential differences in any loop, including those associated with EMFs and those of resistive element, must be zero. So sum of the voltage change have to be zero. So we need to define the term of the junctions. Junction is a point where the three or more conductors meet. So in this figure, I show the two junctions. So three conductors meet at these two junctions. And the loop, any closed conducting path is a loop. So in this case, we could consider the three loop, largest loop of the loop 1, and the smaller loop 2 and the loop 3. Once we find the loop, we could apply the Kirchhoff's loop rule. Then when we apply the loop's rule, we need direction for the sign conventions. So in this case, we consider the travel of the loop. Loop direction of the loop is directed to the right. Then if the direction of the battery is from the negative pole to the positive pole. It becomes positive epsilon. Compare the directions of the loop from the positive to the negative. You should put the negative epsilon. If the current is flowing to the resistors, minus IR. In this case, the current and the direction of the loop is exactly the same. If the direction of the current is opposite to the direction of the loop, then you should put the positive IR. This is a sign convention for the loop rule. Okay, in the first lectures, I explained the EMF, electromotive force, and also the Kirchhoff's rules. Kirchhoff's junction rule and Loop's rule. Okay, this is the end of the first session.